Welcome to today's webinar brought to you by Snowflake, Cinchi, and GridGain. I'm Stephen Fegg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Enabling Broader AI and ML Analytics Adoption, Data Platforms, Tools, and Practices. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible, but if your question is not selected during the show, you will receive an email response. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're excited to have Lucy Zhu, Product Marketing Manager at Snowflake, Dan Demers, CEO of Cinchi, and Lalit Ahuja, Chief Customer and Product Officer at GridGain. Now I'm going to pass the event over to Lucy to get us started. Welcome to the broadcast, Lucy.
Thanks, Stephen, and thanks everyone for joining today. My name is Lucy, and I'm a Product Marketing Manager for AI and ML at Snowflake. And today I'm going to share more about Gen AI and large language models, or LLMs, and how Snowflake is bringing LLMs to the data to enable broader AI and ML for all. Before we get started, here are some required legal disclaimers, and we'll jump right into the content. So while Gen AI has been around for a while now, ChatGPT has made LLMs more accessible and more understandable than ever before. Since the mass introduction of ChatGPT, there's been a ton of activity with Gen AI and LLMs, and many of you have probably even tried an LLM for yourself, whether it's through a chat interface like ChatGPT with OpenAI, or any of the other open source or proprietary models that are publicly available today. A lot of these models are hosted externally and are trained with public data from the internet. But what still hasn't happened yet are LLMs or Gen AI that are trained or fine-tuned with your data. And one of the biggest questions with this is, how will you protect that data? This is particularly important since protecting sensitive or proprietary data like source code, PII, code bases, and other sensitive data sets along with those prompts are really top of mind for models trained with your data. And another question is, where will all that data be and those models be hosted? Many companies want to use an LLM, but the choice that they're really wrestling with is to either self-host an open source LLM like Llama, or use an externally hosted LLM like OpenAI. For that self-hosted open source option, you can go to Hugging Face and grab an open source LLM and host it in a containerized environment, for example. And if you do this in your security perimeter, then you can be assured that none of your sensitive data or prompts are leaving your organization. But the problem and the trade-off with this is that you're limited to publicly available open source LLM models, because all of those cutting edge commercial LLMs have so much proprietary IP, and those vendors want to keep those models hosted separately on the cloud. For the externally hosted proprietary LLMs, you can get access to leading third-party models with minimum infrastructure management. But the downside with that is that you're always wondering, what is happening to all of my data and my prompts? And so traditionally, the decision kind of boils down to, do I focus on privacy and security so I only use open source LLMs in my account? Or do I focus on getting access to some of the leading LLMs without the operational burden, but have to worry about risk exposure? So there's a real trade-off there between privacy and security with development speed. And Snowflake is building a platform that gives you the best of both worlds. So what we're doing at Snowflake is building a platform that gives you access to LLMs without trade-offs. From the beginning, Snowflake was founded based to enable data to be stored and processed all within that same governance. And data scientists and data engineers can go to Snowflake and benefit from the role-based access controls and make sure that all the proper governance for that data is in place. And these role-based access controls really help keep that data secure for not only traditional machine learning, but also the world of Gen AI and LLMs. So what we're doing for Gen AI and LLMs, we're doing that in 3 big ways. So the first is getting smarter about your data. So Snowflake has a ton of proprietary LLMs that we're developing to help you better manage your data. Specifically, we're focused on addressing the challenge with processing and getting insights from unstructured data types, which is one of the fastest growing types of data, and this includes audio, images, video. And so what we have developed is what we call Document AI, and it's a first-party Snowflake LLM used for document intelligence. And it lets you extract content from your documents securely using pre-trained models, and you can also fine-tune those models in your Snowflake account using your own documents. The second capability is focused on enhancing user productivity. So productivity of users can increase with built-in functionalities in the Snowflake platform. And this includes first what we call text to code, which is natural language processing so that you don't have to rely on analysts that know SQL to work with data. And now everyone can go and ask questions and get answers from their data, while all that security will be managed within Snowflake. We're also developing semantic search, which is an AI assistant for the Snowflake marketplace. And the third bucket here is focused on bringing all types of LLMs to your data. And this includes open source LLMs like Llama or proprietary commercial ones like Reka. This last bucket is where I want to focus on the most. We want to give you all the components that you need so that you can run, manage, fine-tune, and deploy LLMs where your data lives. So with this, you don't have to move a ton of data into external environments or procure your own large clusters of GPUs. What we're building at Snowflake is a platform where enterprises are assured that their sensitive data stays within the perimeter of their Snowflake account, but also commercial LLM providers are assured that Snowflake provides the right level of IP protection so that those vendors are comfortable bringing and offering their LLMs on Snowflake Compute. I'll go over the Snowflake platform for LLMs and a few innovations that we recently announced to make all of this happen. So at a very high level, customers today store and manage their structured and unstructured data in Snowflake, and all of that is governed and secured. And this is what we were showing at the bottom layer of this image. Snowflake has always allowed users to easily connect to external LLMs like ChatGPT. And this is in large part enabled by our acquisition of Streamlit, which is a Python library that allows you to build web applications. With Streamlit, you can use chat elements like sd.chat that let you build chat applications really easily using only a few lines of Python code. So on the left side of this diagram, you can see that customers can use their Snowflake data, connect to an external LLM using external functions or Snowpark external access, and then build a front end for that LLM app with Streamlit. There are also a ton of use cases where you want to use an LLM, but you don't want your data to leave your organization. And Snowflake is heavily invested in making that happen. So Snowflake enables any LLM to run inside Snowflake's security perimeter with a new product announcement we made in June called Snowpark Container Services. Snowflake was born into a world where everything in SQL was super efficient to process. Then we announced Snowpark to give you the libraries and runtimes you need to deploy and process non-SQL code like Python, Java, and Scala. Snowpark Container Services is a new runtime in Snowpark that lets you run any code that you want all within the Snowflake governed boundary. This lets you run, fine-tune, and deploy open source and commercial LLMs like Llama all within the security perimeter of your account without any data movement. Snowpark Container Services also provides the infrastructure and building blocks for us to run our own Snowflake first-party LLM models. And some of the examples I touched on previously are also highlighted on the top right, which includes Document AI, text-to-code, and more meaningful search capabilities. And all of this is powered by the same underlying infrastructure. Because all of this is enterprise grade with tons of security and governance built in, we are working with some of the largest enterprises like Goldman Sachs as our design partners to build this platform. A key component of this is that we're enabling commercial LLMs in your own security perimeter within your Snowflake account. We have third-party LLMs like AI21 Labs and Reka that are building proprietary LLMs, and they're excited to bring that model to you without any data movement outside of Snowflake. How we're doing that is packaging these commercial LLMs and bringing them to Snowflake with Snowflake native apps, which is how we wrap third-party applications to run inside your account. LLM vendors can provide a native application on the Snowflake marketplace, and when you install that app in your Snowflake account as a customer, Snowflake will then register the application endpoints APIs and provision a Snowpark container for you that runs in your Snowflake account. So then when you send data into the LLM that runs on Snowpark container for services, none of that sensitive data will leave your Snowflake account, and none of that data is going back to the provider either. For commercial LLM providers, this platform also provides them reassurance that they need to offer their LLMs to Snowflake customers. Because Snowflake is brokering the compute and managing deployment of the LLM into the end customer's account, we can make sure that the only way that the customer can interact with the container and the sensitive IP like model weights from the commercial LLM vendor is through the API that the LLM exposes. And this is a key differentiator of the Snowflake platform, and allows us to develop partnerships with companies like Reka, NVIDIA, and AI21 Labs to bring their LLMs and generative AI to the Snowflake platform. This platform allows you to use any LLM that you want to use, so open source, commercial, or Snowflake provided in your Snowflake account. And for the applications that you are building, you can use Streamlit as the front end. And we already have over 10,000 apps built on the Streamlit Community Cloud today. So that was a really quick but broad overview of how Snowflake is enabling broader LLM adoption. And to learn more about everything we just went over, you can first check out the Gen AI and LLM School that we just launched. This includes 3 free instructional tracks about how to bring LLMs and other Gen AI to your data, with separate tracks for both executives and developers. There are also talks in there from amazing speakers like NVIDIA CEO Jensen Huang. And second, we have a blog post here that demonstrates how to run Llama in Snowpark Container Services. What I have linked here is part 1 of the blog, and part 2 is coming out soon, and that'll include step-by-step instructions on how to bring that open source LLM into Snowflake with Snowpark Container Services. So make sure to check out those resources. And with that, thank you all, and back to you, Steve.
Thank you very much, Lucy. Okay, it's my pleasure to introduce our next speaker for today. We have Dan Demers, Chief Executive Officer at Cinchi. Dan, welcome to the broadcast.
Thanks for having me. I'm going to go ahead and actually share my screen because I'm going to do a live demo as well. So bear with me for 1 sec. I am hoping that you are now able to see my screens, starting with the title slide.
Absolutely.
Okay, great. So hi, everyone. My name is Dan. I am the CEO and co-founder here at Cinchi, and going to talk to you about AI and ML and the relationship it has to the exciting new paradigm shift of data collaboration. You may have seen the film An Inconvenient Truth. Well, here is a truth bomb. Your AI initiatives are going to fail to scale if you don't first solve for data collaboration. And I'll say that again, your AI initiatives will fail to scale if you don't solve data collaboration. But what exactly is data collaboration? Well, before we even get into data collaboration, let's talk about collaboration and how that is fundamentally different than sharing. On the left side, you can see sharing results in integration. If we look at documents as an example and contrast document sharing versus document collaboration, prior to the launch of technologies like Google Drive and OneDrive and other document collaboration platforms, you would still do collaboration by sharing copies back and forth, often as email attachments. And if you're working with yourself, that's fine. If you're working with two parties, it's cumbersome, unsecure, but good luck scaling that to 4 or 40 or 400 or 4,000 or 4 million parties to be able to collaborate where every party is contributing to a single document. Well, thankfully, collaboration technology was applied to the problem of how we work on documents, and that is now no longer the case. I can easily create a document. I can give access, limit that access to read or read-write. And for people who have change access, we can change and do it together in real time. The platform is tracking all the versions, the history. It's safe, it's secure, it's far more efficient, and you don't have to do the merges that you would have to do if you were sharing copies back and forth. So don't confuse data sharing with data collaboration. And this collaboration shift is a really big deal. We've seen it disrupt the enterprise over and over again, how we work on documents, how we message each other, how we meet, how we work on projects. And really the application of collaboration to data is the final frontier. If we contrast data collaboration to the traditional sharing-based approach, you can see how it results in excessive integration. You can see that users use apps. Some of these apps are legacy, some of them are new, some of them are on cloud, some of them are on-prem, some of them are custom, some of them are vendor. Every app stores data, and in order to share it, to enable collaboration, it's doing APIs and ETLs and building all this complex web of integrations between operational systems, to and from your analytics platform, to and from your governance platforms, to and from your spreadsheets. It is an integration nightmare, and the more you digitize, the more that becomes true. By introducing collaboration on data, it allows multiple parties, could be humans, could be systems, could be AI, to work together in real time on the data and avoid building net new integrations. It's not going to undo what you already had. You can't rip and replace. You're going to build on top, but it enables you to deliver in a far more efficient, far more secure manner while leveraging your existing investments. So if it's not already clear, what you're seeing here with data collaboration is not better than the traditional approach. It's actually quite different. So if you think of how does this contrast to a data warehouse or a data lake or a data lakehouse or even a traditional analytics-centric data mesh or data fabric or data virtualization, what they all have in common is they focus on really one aspect of data management, which is scenarios where you have a producer of data and many consumers. And the enablement of managing data as a product really helps all parties, but not everything is as simple as a single producer, many consumer. Data collaboration really solves for the scenarios where a single data product and the business owners can benefit from co-production of that data. So it's not one person write, everyone read. It's multiple parties writing and reading and working collaboratively toward a shared outcome using the power of data. And I'm talking about on an actual data set, like literally picture a conceptual table, different parties owning different columns, different rows, et cetera. And all of this is powered by federated collaboration. The way it works is, of course, it's not an insta-fix. You can change how you deliver change by intercepting the projects that you are going to do anyway and applying collaboration as an accelerator and a risk reducer to those new projects. It starts with the first step, which is whenever you would have otherwise done a new integration, rethink of that as a liberation and use the ability to do bidirectional real-time synchronization to make your data available in the collaborative ecosystem for multi-party collaboration. This could be connecting data from your proprietary on-prem systems, from your modern cloud SaaS applications, from different vendors, from different parties. And by liberating that data, the application teams that own that are no longer a critical path for future integrations to support future projects. It's once and done per system. The next step is for data product owners to create data products, but not just the traditional data product that drives analytics, but truly collaborative data products that support multiple parties to change. So yes, a central place to discover and access with granular controls, but the ability to contribute and work collaboratively towards a shared outcome. This then enables collaboration across the enterprise, whether it's in the context of artificial intelligence, be it ChatGPT or any other large language model, real-time reporting, self-serve, not just data discovery and access, but data management, creation and origination, building any new custom software-based solutions, unlocking advanced analytics. All of this can now benefit from an access-based paradigm using multi-direction data collaboration. Access, not copies. Oops, time for a live demo. So I'm in the platform and we are seeing really our own environment. So you can see I'm logged in as myself here. And you can see that I have access to a number of objects that I can filter down. So for example, if I want to look for a specific data set, so a data product, let's look for one called people. So I can click on that. So I'm able to discover, I'm able to browse, search through metadata. I can see here is a collection of people. Notice that this is a blend of data coming from multiple sources. We've got some records coming in from HubSpot, some coming in from Freshdesk, some that were originated inside of Cinchi. So it can be a system of origination. And I can see the entire collaboration log for any individual record. Just because it came from a system doesn't mean every column came from a system. If I were to go into a single person, so here we're looking at one such person that exists in that single data product. And you can see it's pulling together linked data that was the result of collaborative co-production. So you can see information about the company, you can see information about the person. I can even see psychographics and personality profiles and intelligence that would guide us in terms of how to interact with this person. We have a rich prompt style interface that's, of course, using generative AI behind the scenes. In this case, we're using ChatGPT. And you can see I've asked Ty here a number of questions. I said, where do you work? He answered the question, what do you do? He's the chief data officer. Where did you go to school? I even asked, what was your school mascot? So it's able to connect the data that is available in my network, where it's totally under my organization's control, even on-prem, but with publicly available information. I then asked, on a scale of 1 to 10, how likely are you to be an advocate for data collaboration? He answered a 9. I'm basically chatting with the digital twin of this person. I asked them to write me a personalized email that highlights your unique personality while also highlighting the value that is unique to Cinchi. And it wrote the following. So, hi, Ty, I'm writing to introduce you to Cinchi, the platform that helps organizations manage data. It talks about the unique value prop of a unified data layer and enabling collaboration to work more efficiently. And then it ties personality. So hyper-personalized, but all using modern technologies, including things like ChatGPT, while giving the organization total control over their data. And of course, different models can be easily composed and plugged and played into the ecosystem. So now, where did all this data come from? Well, let's go back to the tabular view of the data. And now I'm looking at the same information, but just structured kind of like in a spreadsheet style interface. But if I right click and select View Collaboration Log, I can see that this has been a byproduct of co-production. I can see that I inserted this record today at 1:20. And then at 1:20, a different system was gained access to the email, where it then turned that into a full name and a title. And then we plugged in Google, and what Google did is it standardized the address. And then I made a change and I populated the person's LinkedIn profile. And then a commercial AI partner of ours, Humentech, then did a personality scan, and their model is trained off of LinkedIn data that basically gave us insights into how Ty thinks and operates. Then you can see we have ChatGPT interpreting all of this to give us that sales advice. And then you can see me making more changes, and then Google making more changes. All of this is done in a collaborative way. There's not separation of data sets. There's no integration back and forth between these systems. They're all using this as if it's Google Drive and they're collaborating on a document. All right. So again, it's the idea of co-production of data sets and creating a federated view over that ecosystem to enable collaboration. If you look at a different example, and I won't spend too much time on this, but if you look at an example of a data product called Employee, which is in the HR domain that's owned by Jane, who's the global head of HR, Jane is the owner of this and is managing this as a product, but has authorized multiple HR systems, HR staff, employees, artificial intelligence to co-produce this data set as an alternative to every silo and doing integrations back and forth. So you can see here we have Workday and PeopleSoft and even HR staff, artificial intelligence, performance benchmarking tools. Even the employees are contributing to this with constrained granular access that limits not only what they can see, but what they can change, approval workflows. So an employee can manage their own pronouns, but the AI can predict their performance rating, and HR can override the system of record that then updates the system of record depending on your configuration. This is just one of an infinite number of examples of collaborative data products. What's really interesting is the ability to collaborate not only on a single data product, but the ability to collaborate across these data products to form a network. So as you're using this approach to deliver your very next project, the project that follows that is able to reuse what was there. Each individual data product is collaborative, but it's creating this compounding benefit of collaboration as you deploy more and more change inside of your organization. All right, so back for another demo. And I'm gonna flip into a different screen here. So what you're seeing is our data network, our live data network. So we looked at, for example, an object called people. Well, I can see that there's an object called people. I can see how it's connected. But what's important to note is that this view is constrained to my access in the present. And if I'm logged in as a different user, I'm going to have different access. And that access will limit not only which data products I can see, but which cells of data I can see and what I can change. And if I need that change to be approved, and providing extreme control with precision where needed. You don't always need it, but often you do in an enterprise context. So I'm actually going to stop my screen share for a second and reshare a larger screen. Give me 1 second. And I'm hoping you can now, and Stephen, if you can confirm, can you see my entire screen, including the window that I was just sharing?
That is correct.
Okay, perfect. Okay, so what I have here is we were looking at the concept of a person before. I'm now looking at the concept of an employee. But you can see on the left side, I'm logged in as myself, and I'm looking at my own employee record. Where on the right side, I'm using a test account that simulates an employee that works in the organization, but is not me. So two different logins, just a side-by-side view, and they're both opening the 360 for me as the head of company success, the CEO and founder of the company. And as I click through on the left side, like if I go to About Me, you can see there's an AI summary of me. There's my own self-drafted profile. On the right side, this person has access to that, but cannot change it. So the About Me here is read-only, whereas on the left it's editable because I have the ability to make edits to that. You can see my personality characteristics, and that is also permitted. I've enabled sharing of that. But there's a whole lot of information on the right side, for example, performance reviews and compensation and stock options. And all these things are, of course, not available to this test employee. Whereas I'll be able to see but not change my own data and see that of my staff. And all of that is defined within policies of whoever ultimately owns the data product that defines that and governs that. But in the same way that we saw a chat style interface, I'm going to do the same thing here. And you're going to see that I ask the same questions, but against the digital twin of myself, but using these different accounts. So on the left, as myself, I said, are you older or younger than Bill Gates? It answered younger because I, Dan, have access to know my own birthday, therefore my age. And Bill's age is obviously publicly known, therefore it knows the answer. But on the right side, this employee does not have access to my birthday, therefore has no idea if I am older or younger than Bill. So it says, I don't know. I then ask, what was your first job? Both of them answer that correctly. What is your superpower based on the personality profile? Apparently mine is problem solving. What are some of your personality quirks? And it's very similar in terms of the answer because it has the similar level of access. But on the left, under my own account, I say, what famous I guess it should be people, were born in your city. And it answered, because I was born in Toronto, and you can see that there's 3 names here, but on the right side, it doesn't know where I live. It has no idea, so it cannot answer this question. All right. So just to summarize, we talked at the beginning around how your AI initiatives are going to fail to scale if you do not solve for data collaboration. And hopefully what I've shown you gives some light into that. And the big theme there is around the simplicity and the control. However, sometimes the opposite of a truth can be another truth. So while this message is very negative, let's look at the other side of it, which is a very convenient truth. The other way to look at it is your AI initiatives can succeed and scale if you first solve for data collaboration. So we talked about artificial intelligence. We talked about data collaboration. You put them together and the magic happens. If you want to find out more information, you can check us out at cinchi.tv. We have a ton of content that goes deeper into some of the concepts I introduced today. And thank you.
Fantastic. Thank you very much, Dan. Okay, it's my pleasure to introduce our final speaker today. We have Alit Ahuja, Chief Customer and Product Officer at GridGain.
Hello, everybody, and thank you for joining us today at this DBTA Roundtable event on enabling AI adoption. Today, I'm going to share my thoughts and my perspective with you around enabling AI adoption and expediting the AI lifecycle. Before we go too deep, let's take a quick look at some of the use cases where AI has been successfully used. Let's start with banking and financials, use cases like credit card fraud detection, where you swipe your credit card and there's something in the background that executes to decide if this transaction is fraudulent or not. Financial risk analysis, pricing of assets, whether it's options or bonds or whatever, or other more novel assets. In the manufacturing space, there are use cases like predictive maintenance, smart factories or autonomous machine-to-machine operations. You see use cases in the retail like dynamic pricing, like understanding or determining customer preferences or customer sentiment based on their history and so on. Making recommendations to your customers based on their past behavior and what they have in their shopping cart and so on. Around healthcare, there are use cases and uses of AI around drug discovery, more commonly known as computational drug discovery, or with patient care and being able to predict patients' health patterns and so on. Logistics and transportation has use cases like telematics and routing of goods and services from point A to point B in the most optimized fashion. And if there's a problem, how do you find the best alternate routes and so on? And there's obviously pricing as well. So all of these use cases are not very novel, not very new, not something that we may not have heard of or we are not aware of. So if these use cases exist and you see uses of AI around you, why is it that AI adoption hasn't yet been as much as what we predicted 10, 15, 20 years ago? Why hasn't it taken off too much? I did some research. I looked at a lot of content and found some numbers. This is an average of a bunch of different numbers from different sources, so it's not entirely accurate, but I broke it down into 3 categories, at a high level, 3 major barriers to AI implementation. About half the people, 47% of the people at our enterprises have been hesitant to embark on that AI journey because of challenges around data and technology. Everything from challenges with accessing data across their data ecosystem, across the enterprise, challenges with data quality, their inability to process all the necessary data. There's a large amount of data that they have to process. Can they do it easily? Can they do it quickly enough that it actually gives them the value and so on? And there are questions around data security, data privacy, data governance, and the technological concerns around these factors around security and privacy and governance and so on. Can I put my data in the cloud and is it okay? And can I make it available so I can run a large amount of AI compute and so on? So lots of different factors that play into it. 38% of enterprises thought that they could not determine the business value of embarking on an AI program of work. The inability to determine measurable business value. If I make an X amount of investment in an AI program of work, will I get an X plus Y benefit or value out of it? The lack of understanding of the benefits of AI and the uses of AI, difficulty in finding appropriate use cases where I could actually leverage or apply AI to get to my answers easier, better, faster, or more accurately, and so on. And about 15% of enterprises were hesitant to embark on AI program of work because of lack of skills, whether it's just the skill of the staff, the resources available to them, the technology available to them, their understanding of the technology that's out there that's available for enterprises to be able to leverage AI successfully, and the inability of people to understand how it works. How does machine learning work? How do you what's features, what is feature development, feature engineering, what's model, what model to pick, how do you execute, train your model, and so on. So lots of those technical challenges that people have because of their limited understanding of AI. So that's kind of the breakdown. We won't talk a lot about business value or how do you improve the skills of people and so on, but let's focus a little bit on that big half of enterprises, or nearly half of enterprises, not embarking on an AI program of work because of data and technology. Let's see what's happening there, and let's see what we can do about that. We'll start with the AI lifecycle. As circular as this picture is, AI lifecycle is not quite as circular. You typically start with a business problem. You have a question that needs to be answered. I'll go back to the good old credit card fraud kind of a use case. I'm swiping my credit card for a transaction. Is that transaction fraudulent or not? That's the problem, let's say, the business is posing. I want an automated, intelligent answer, consistent, intelligent answer to that question. Is this transaction fraudulent or not? You have to you start with that question, then you look at the data that you need to be able to answer that question. Then you look at what you have to put together, what you have to calculate, what you have to compute to be able to get an answer to that question. You have to create a model that can then be executed based on that incoming data. You have to obviously execute that model. And then you have this whole thing around management of this whole program. So, whether your model deployment, your version control, your test data, your training data, because all of these things feed into your model. So all of these components go into your AI lifecycle. And then once you do the execution, then you have the answer, the decision that's made. Yes, this transaction is fraudulent, or no, it's not fraudulent. Let it go through. So that's sort of at a very high level, your 4 stages of your AI lifecycle between the problem statement and the outcome. Let's look a little bit deeper into these 4 categories. Data acquisition can be broken down into 4 or 5 different things. You have to be able to access data from multiple sources. You have to be able to ingest data from multiple sources, put it together to be able to then use that data to be able to make a decision. You have to visualize that data. So once you can visualize the data, you can see what patterns are there, what data elements correlate, what do not correlate, what data elements would feed into being able to make the decision or provide an answer that you're looking for, and so on. You got your data pipelines, which is where you not only do you ingest data from multiple sources, but you have to manipulate it, embellish it, aggregate it, collate it, or whatever you have to do with it. All that manipulation has to happen. And then finally, obviously, you have your data store. This is where your data is stored. This is where you access it from. This is where you pull your historical context and so on. Again, we'll talk about that a little bit in the scope of that credit card transaction. On the modeling side, there's something called feature engineering. This is where you take your raw data and you convert that into what you call your features. And you have to obviously define those features and then what data ties to features in what way and so on. Those features also have to be stored in your feature store. So you got your raw data store, you got your feature store that has to be stored and to be able to access those features quickly and so on. You have to pick the right model, you have to train your model, you have to test your model, you have to make sure that your model gives you the right answer X number of times. So if I run my model 100 times, at least 99 times out of 100 or 995 times out of 1,000, I'll get the right answer. That's where you evaluate your model. You make sure that your model is giving you the right answer. It's something that you can rely on to make a decision. The reliability factor depends on the intensity, the magnitude, the criticality of the decision. Customer sentiment, are they happy or unhappy, is one level of on one side of the spectrum in terms of making a decision. should I administer this particular medication to this patient who's in a critical state right now, is a very different ballgame in terms of the reliability you will have on your model. And then you got your model execution, everything from transaction invocation. I swipe my credit card. As part of that credit card swipe, I want to be able to make a decision whether it's for a fraudulent transaction or not, or an event that gets fired, like a smart grid firing off an event. You analyze the event, you figure out what's happening with that event in the context of your grid. Do I have to add more load? Do I have to take off load from the grid? And then you make a decision. That's the whole execution side of things. And then you got your AI ops, everything from deploying your model to version management, not only of your model, but also of your test and training data, to be able to redeploy a model based on changes that happen and so on. So all of that goes into your AI ops. And so that's sort of the breakdown of your technology around AI. Now, what does this mean? And how do you look at this, and what do you do with this information? Now, let's look at some critical success factors. You have to have data available in a timely fashion. At the end of the day, if you do not have the right data available to you at the right time, your AI model, your ML model, or whatever it is, will not give you the right answer. The quality of your answer is only as good as the quality of the data that feeds into it. So timely availability of your data is important. You have to be able to process that data, all that information, your event, all that contextual information. Again, if you look at the credit card transaction, a single swipe of that credit card at a gas station in Los Angeles, is that fraudulent? Who knows? Maybe it is, maybe it's not. I can't tell. Nobody can tell. But if you put that in the context of the fact that an hour ago or a half hour ago, you also used that same credit card to pay for a meal at a restaurant. When you combine the two things together, the fact that LA and San Francisco are about 500-600 miles apart, combined with the fact that even if you're flying, it'll take you, an hour and a half to in flight to be able to get from San Francisco to Los Angeles. It is impossible that you're the same person with the same credit card who swiped the card at LA and half hour ago swiped it in San Francisco. So in that context, the transaction can be deemed as fraudulent. But to be able to do that, you have to combine all this information, this contextual historical information, and execute the model to be able to make that decision. And then you got your AI ops. If without your AI ops, without knowing what your model life cycle is, where your model is it the latest one against the data, so on and so forth, it won't work. So what is key here, the underlying key here, if you look at it, is your ability to process an incoming transaction, a credit card swipe or whatever, your ability to pull the right contextual data, understand what that contextual data is, pull it together, combine that with your transactional data, make it available to a compute engine, execute that compute at low latency, high performance, high speed, or whatever, and then make a decision. Execute your model against the data at high speeds and make a decision. So 4 key components, if you look at it. You got to be able to process data at rest. You got to be able to process data in motion. You got to be able to contextualize what's happening, combining your data at rest and in motion together. And you got to do all of that at low latency, because if you don't do it at low latency, because if you can't make a decision on whether a credit card transaction is fraudulent or not using AI in a reasonable time window of, a bunch of milliseconds or, very, very low number in half a second or something like that, then nobody wants to use AI to be able to make that decision. AI doesn't have the value if you cannot execute and process it and arrive at a conclusion or make a decision within a reasonable time window. So data at rest, data in motion, contextualizing it, executing all of this together, that model in real-time low latency is what are the key factors. How do you put all these together? Well, there happens to be something. It's called a unified real-time data platform. What is it? It's a platform that, while it simplifies and optimizes your data architecture, but it does that in a way that it combines streaming data in motion with historical data at rest, being able to put that all together and execute some complex compute workloads on top of it to be able to help you arrive at a decision. It allows enterprises to do this while also having them accelerate and expedite their entire data ecosystem, do it at speed and scale and high availability. What are those core components that make up a unified platform? Again, the ability to process data at rest and data in motion, the ability to execute complex workloads on top of that data in rest and data in motion combined, and to be able to do it at ultra low speeds and in real time. If you put these 4 things together, you have a winning solution or a winning package in terms of capabilities to be able to address what you're looking for having those AI use cases implemented. What are the core capabilities or the components of a unified real-time platform? Obviously, it has to be able to process transactions at high speeds. It has to be able to execute complex analytical workloads at high speeds. It has to be able to aggregate data, putting it together to make it available for these complex workloads and AI models. That's where a data hub comes into play. It has to be able to pull data, historical data. That's where being a system of record comes into play. And obviously, I talked about stream processing and so on. And then finally, your AI and ML operations to be able to manage your model and your data and all of that together. So ability to process transactions, ability to run complex workloads and execute complex models and so on, make data available in real time, historical and current transactional data, all of that together is what is needed from an AI platform. Now, there are some platforms out there that do those kinds of things. GridGain happens to be one of those platforms. It combines your high-speed transaction processing with advanced analytics, stream processing, system of record, data hub capabilities all together into a single platform. How does it do it? It does it with extreme speed and scale because it leverages distributed in-memory computing, co-locating your data with your processing, so putting your data and your processing right together with each other, so there's no movement of data over the network, and allows you to eliminate that network latency, that latency of moving data across silos and so on. And what you get out of it is you get a technology solution that allows you to expedite your AI implementation lifecycle, everything from data acquisition to data modeling to deployment, and execution, all of that done within a reasonable amount of time. Hopefully, this gave you some insights into what it takes to be able to execute an AI program of work. Thank you all for listening. I appreciate it.
Thank you very much, Lalit. Okay, we're going to go into questions from our viewers today. And the first question I have here, which I think it would be great if each of you could weigh in and share your thoughts on, is as follows. How important is fostering a data-driven culture within an organization for successful AI and ML analytics adoption? And Lucy, if you don't mind starting us out on this one.
Sure, happy to. So I think from a Snowflake perspective, from our inception, we've always been about bringing the compute to the data rather than the data to the compute. So providing this single platform for storing and processing your data with security and governance. So I think from a Snowflake perspective, it's incredibly important to foster that data-driven culture to enable that successful AI and ML analytics adoption. And, here at Snowflake, that's what we're doing and that's what we're driving towards is, if you're already storing all your data with Snowflake, then using Snowflake for AI ML becomes a no-brainer. And as we chatted through earlier, what we're doing is building a platform for LLMs and AI so that, you can use your data in a secured and governed way and bring LLMs to your account using Snowpark Container Services and Snowflake native apps, and doing all of that within your security perimeter. So really allowing you to bring that LLM compute to the data where it lives.
Understood. Thanks, Lucy. Dan, how about you? Would love to hear your thoughts on this.
Yeah, and the question was around culture, and short answer is it is important, but you can't just tell people to change their culture. You have to lead the way by having your early pioneers demonstrate success such that others even want to follow, which is the best way to drive cultural transformation. But of course, if your organization doesn't care about it, you're going to fail in doing it, and that has to start at the top.
Understood. Absolutely. And Lalit, would love to get your thoughts on this as well, the importance of fostering a data-driven culture for successful AI and ML adoption.
Absolutely. Can you guys hear me okay?
Yep, you're coming through.
Excellent. I'm just getting out of an airport, so it's a little challenging. But basically, to that question, You can go with one or two use cases very easily without really fostering a data-driven culture around your AI and ML analytics and so on. But if you want to go further, you want to make a practice out of it in a way that you can leverage it across your enterprise. It is imperative that you have something, some sort of a framework around your data and in the enterprise itself. As you heard from me, others here, and I think a couple other presentations as well, the scope of data for an enterprise has changed a lot. It is no longer one or two applications, no longer what within your enterprise within your four walls, but it's gone beyond your enterprise. It's your social media, it's your news feeds, it's what's happening in geopolitical situations all over the world. And all of that impacts what you do in your enterprise, what decisions you make. And for you to be able to leverage all that information successfully and appropriately in a timely fashion, so you can make that information available to your AI and ML models in time, you have to have some sort of a framework which allows you to access all that information appropriately, correctly, and at the right time. And that's where having that culture around being data-driven as an enterprise, making sure you have your data available, making sure the right kind of information is accessible, again, with the required security and governance and so on. So this becomes very important, because at the end of the day, like I was saying earlier, your AI will only be as good as the data that feeds into it. And if you don't have the right information at the right time to be able to feed into your AI models, you will not get the most accurate answer.
Understood. Thanks, Lalit. Okay, Lucy, we're circling back to you. This is a question specifically about Snowflake. Does Snowflake support a model where customers can store their data on-prem?
Yep. So Snowflake is a service that runs completely on cloud infrastructure. So we're cross-cloud. We run on top of all the major cloud providers, so GCP, Azure, and AWS. And so to use Snowflake, you really have to use cloud. And what we're building here is actually called the Snowflake Data Cloud, and it gives you access to, Snowpark Container Services, Snowflake native apps, Streamlit, all of it. But yes, it is completely on the cloud.
Understood. Thanks, Lucy. Dan, our next question is for you. Lots of buzz surrounding generative AI and ChatGPT. You stated that data collaboration is key to enabling the scaling of AI. Can you elaborate on that?
Yeah, the key there is control. If you recall from the demo where I was asking an employee questions using two different accounts that have different level of access, and those questions were, of course, using a large language model that was trained on the data, but they were getting different answers because they had different level of access. And that is critically important. Without that, you cannot deploy it against PII and give your workforce access to that. You need that universal control layer such that it's guaranteed to be consistent, regardless of who's asking and what context they are, to make it so that, as you're interacting through a prompt style interface, you're not getting accidental access to data that you should not have. It should be as safe as if you tried to ask my dog what my deepest, darkest secret is. No matter how much you interrogate the dog, it ain't going to tell you because it doesn't know. That's how we have to treat AI.
Understood. I love that example. Okay. The next question is for you. Can you elaborate on why accessing or processing data at rest and in motion together is a requirement for AI adoption?
Absolutely. I'll go back to the good old example of credit cards again. What's happening if you just follow through the workflow of that example? You swipe a credit card at a store in Los Angeles, at a gas station, whatever, and you have to determine that the transaction is fraudulent or not. Now, just that atomic information, that one event that says, I swiped my card at a gas station in Los Angeles, tell me if they should go through or not, is not enough to be able to say that the transaction is fraudulent or not. What is needed is what else has been happening around that transaction, in the context of that transaction, before that transaction occurred, in the scope of that credit card holder's account or whatever. So when you look at that, you have to know that, did this person swipe their card somewhere else a while ago? Did this person have an air ticket to Los Angeles? They live in North Carolina. How come they're in Los Angeles? Were they at a gas station or a restaurant in San Francisco a little bit ago? So to know that, you have to go back to historical information. That's the data at rest. So this data in motion, this event of a credit card being swiped, combining with the data at rest, which basically is telling you that in the past, there was a transaction for payment at a restaurant in San Francisco, or there was a transaction that was made around purchasing tickets from North Carolina to Los Angeles. That information has to be put together with this transactional information to be able to make the decision appropriately. Now, obviously, it's not just pulling this one event of a payment in San Francisco or an air ticket from North Carolina. It's hundreds of these events that you have to put together from the past and combine that with this event. And that's where putting this event, which is the data in motion, and a history of transactions, which is data at rest stored somewhere in that data ecosystem, made available to your AI model, is what has to come together to be able to give an accurate answer. That contextualization is important, without which you won't get the right answer.
Got it. Thanks, Lalit. Okay, and I see that we have had a number of questions come in inquiring about demos or free trial software, things of that nature. How can I get so-and-so to follow up with me? So I think before the end of today, I will give each of you an opportunity to, if you want to mention where folks can go to test out some things, we can do that at the end. And in addition, of course, if you would like one of these companies or all to follow up with you, we do provide the sponsors with, a list of these questions so they can follow up with people that are interested. So our next question is for you, Lucy. Does Snowflake support particular LLM frameworks, OpenAI, Hugging Face, et cetera, or is it based on the proprietary model inside Snowpark?
Yep, that's a great question and a good clarification if that wasn't clear earlier. But essentially what we're building here is a platform that supports any LLM. So that includes any open source LLM like Llama, anything from Hugging Face, ChatGPT, as well as proprietary commercial ones for companies, vendors that we have partnerships with. So that's like Reka or AI21 Labs. So all of that can be packaged into Snowflake with Snowpark Container Services, and then you can use Snowflake native apps through the Snowflake Marketplace to get access to those in your account. So from an open source perspective, there's really no limitation there.
Understood. I see right now we're at about a minute left before 3 p.m. Eastern. So at this point in time, I'd like to ask a question of each of you. And Dan, why don't we start with you? If there's one thing that you would like our viewers to walk away today, keeping in mind, what would that be? And as I mentioned before, if you can shed any or provide any, guidance on where folks can test out your software or find out additional information about Sinchi, please do.
Yeah, for sure. So the one thing I think would be what I mentioned in the presentation at the beginning and end, which is if you don't understand and apply data collaboration, you're going to not be successful in deploying AI at scale in an enterprise context. So definitely data collaboration is a prerequisite. There's lots of vendor marketing that uses the word collaboration, but definitely focus in on data that is co-produced across an enterprise context, because AI is part of that co-production network. It's critically important. And if you want to find out more, you can check out Sinchi.tv, where we have a bunch of video-based content, or our traditional site, Sinchi.com, if you want to find out more and just really learn about this concept of collaboration on data.
Fantastic. Thanks, Dan. Lalit, why don't we go with you next?
Sure. I cannot say this enough. Anything you want to do with AI, if you want it to be successful, you have to make sure you have data available for it. That's the most important thing you can do if you want to have an AI program or for it to be successful. So any enterprise, anybody who's looking at leveraging this amazing capability and tool has to make sure that they have the right kind of information available, whether it's to train your models, whether it's to test your models, whether it's to evaluate your models, or whether it's in real time, transactionally, you want to actually make a decision. So getting your act together around having all of your data arranged properly and appropriately so you can make it accessible easily in a fashion that is extremely fast and scales. There are lots of ways you can go build data hubs today, leverage those tools, and make sure that you can have this information available to your AI tools and AI models to be successful. Feel free to reach out to anybody here at GridGain. You can go to our website. You can just send an email to support@gridgain.com, and we'll gladly work with you to help you get to that point.
Awesome. Thanks so much. And last but not least, Lucy, if there's one thing you'd really like our viewers today to walk away keeping in mind, and of course, your recommendations for any additional resources, things, the folks on with us today might like to check out.
Got it. Yeah. So my final takeaway here is, Gen AI and LLMs are here to stay, especially for enterprises. This is a big investment area across the board, and data security is really top of mind for all companies that are experimenting and looking into LLMs. How do I keep all of my proprietary data, my prompts secure and governed, while also tapping into the potential of LLMs? What we're doing here at Snowflake is allowing you to bridge that gap, using your own proprietary data to feed these models for more accurate insights, but also making sure that you're ensuring that your data and prompts never leave the security perimeter of your account or your organization. So to learn more about, what we're building here, what Snowpark Container Services and Snowflake native apps, highly recommend you check out the LLM and Gen AI School, as well as the blog post on, just step by step, how does it all work under the hood when you bring in a Llama model into Snowpark Container Services as an example.
Fantastic. Thanks, Lucy. That is all the time we have for questions today. I know there were some questions that we were unable to get to. We're sorry. We will share your questions with the speakers and the sponsors for this event so they can follow up with you and you can connect offline. I'd like to give a huge thank you to our speakers today. Once again, Lucy Zhu, Product Marketing Manager at Snowflake, Dan Demers, CEO of Sinchi, and Lalit Ahuja, Chief Customer and Product Officer at GridGain. We appreciate you coming on board and sharing your insights and expertise. If you would like to review this presentation or send it to a colleague, you can use the same URL that you used for today's live event. It will be archived and you will receive an email once the archive is posted. And as I mentioned before, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced, looks like next week on August 31st. We'll let you know if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.